Hello, welcome back to my channel. So today we are going to talk about a bit of chemistry. So my name is Ayush Kumar. My USN is 1VE23CS022 and I'm from second semester. My section is Audi and my subject is BCHES202 and my subject is Applied Chemistry for CS3 and our course teacher is Miss Sunita Rani and let's get started. So my topic today is introduction to corrosion prevention in chemistry. So what's corrosion? Like corrosion is a major challenge in chemistry that can lead to degradation and failure of materials. This presenting will explore various methods for preventing corrosion, including cathodic protection, anodic protection, protective coating, alloying, and more. Let's get started. So first, at the cathodic protection, the first method we have, which is a sacrificial anode. So usually sacrificial anodes are used in terms of like hulls at the ships because as you can see in the photo, that is a hull, and those are turbines which would be submerged inside the water, and it will be electrocuted so that it does not catch any kind of rust. So cathodic protection uses less noble metals such as zinc or magnesium, as shown in the photo, to act as a sacrificial anode and protect them the more noble metal structure. So for example, as you can see, we have another one, which is basically impressed current. That is a second method which we would be using to prevent corrosion. So this is an external power source applied a small current to the metal structure, making it the cathode and preventing corrosion. As you can see over here, the same thing which you have done over here is basically an external power source is applied to the anode so that it does not catch any kind of corrosion. Third, we have an effective cathodic protection, which is highly effective at preventing corrosion in a variety of environments, including an underground pipelines, marine structure, and storage tanks. As you can see, there is a underground underground pipe being repaired so that it does not corrode due to any other reason. Next, we have anodic protection. So before learning more about anodic protection, we should know what is its principle and how it works and what are the applications that may lead to its effectiveness. So anodic protection works by maintaining the metal in a passivated stage where a thin protective oxide foam forms on the surface. So next we have the application. So anodic protection is commonly used to protect stainless steel and other high alloy metal in chemical processing equipment, storage tanks, and power plant components. Advantages. So anodic protection is highly energy efficient and can provide long-term corrosion protection with minimal maintenance. So next, there is the next thing, which is basically protective coating. Now there are four things which may help us to fight back against corrosion. First, we have paint and enamels. Second, we have metallic coatings. Third, we have polymer coating. Fourth, we have more application methods which may be helpful for preventing corrosion by adding a protective layer or coatings. So first, we have paints and enamel. So traditionally, what we do is organic coating that provide a physical barrier against corrosive environments by applying paints on the surface of the metal so that there is no corrosion being formed. Next, metallic coating. So in metallic coating, we usually use zinc or chromium or a nickel that offers sacrificial and barrier protection to the surface of the metal. Next, we have polymer coating. So modern high performance coating made from polymers and ceramic that provide excellent corrosion resistance. Now, there are many application methods that may have not made to the list, which includes like spraying, dipping, or electro deposition. So next we have alloying. So there are four types of basically alloys: steel alloy, aluminium alloy, titanium alloy, and nickel alloy. Steel alloy. Adding elements like chromium, nickel to steel can signify improve its corrosion resistance. Aluminium alloys. Alloying aluminium with elements like copper, magnesium, and silicon can enhance its corrosive properties. And aluminium does not get corroded that easily due to that. Next, we have titanium alloys. Titanium alloys are highly resistant to corrosion but they also come with a cost, because titanium is one of the rarest materials which we usually get, so making them ideal for use in harsh chemical and marine environments, which would be useful. Next, we have nickel alloys. Nickel-based alloys are renowned for their exceptional corrosion resistance, often used in petrochemical and aerospace industries. Next, we have galvanic isolation, which is dissimilar metals, isolation techniques, and effectiveness. So, dissimilar metals, when two dissimilar metals are in contact, a galvanic couple is formed, leading to the accelerated corrosion of more reactive metal. So, isolation techniques. This is the second topic, which is measure like insulating fasteners using dielectric coating or incorporating sacrificial anodes can help prevent galvanic corrosion. Effectiveness. Galvanic isolation is a crucial strategy for preventing corrosion in application where dissimilar metals are unavoidable, such as automotive and marine environments. Next, we have corrosion monitoring. So here there are four types. One is inspection, electrochemical techniques, predictive modeling, and preventive maintenance. So inspection, regular visual inspection and non-destructive testing can help detect and access the extent of corrosion in infrastructure and equipment. Electrochemical techniques, advanced techniques like electrochemical, impedance spectroscopy, and linear polarization resistance can provide real-time data on corrosion rates, which will effectively not completely get rid of corrosion, but it can resist it to the maximum possibility. Next, we have predictive modeling. Computer models and some simulations can help predict the long-term corrosion behavior of materials and guide maintenance strategies. So basically, computer nowadays can predict certain things in a most accurate way, which humans can hardly think of, and it can also predict a certain ways which we can see like a particular thing, like for example, iron which is mixed with another material. So it will basically see like how many months or days it can sustain without having a protective layer, or without galvanization it can be without getting corroded. Next, we have preventive maintenance. Implementing a robust corrosion monitoring program can enable proactive maintenance and extend the service life of critical assets. So the critical assets which I mentioned, they might be usually the tanks, fighter jets, or any other things which may have a chance of getting corroded. So it is a high time that we keep a monitoring system, which they should be checking time to time, so that there should be no certain thing. Next, we have come to the conclusion of the video, in which I'll be listing all the prevention methods and the key benefits of it. It's basically a short summary. So first we have cathodic protection. This is high effective in variety of environment, low maintenance, which is usually used by many people. And anodic protection, which is energy efficient, long-term corrosion prevention, protective coating. Wide range of options can be tailored to specific application, allowing improved corrosion resistance for metal like steel, aluminum, and titanium. Galvanic isolation, so prevents accelerated corrosion due to dissimilar metals. Next, we have corrosion monitoring, enables proactive maintenance and extends assets life. So by implementing all this corrosion prevention strategies, it is possible to effectively protect materials and equipment from the damaging effects of corrosion in a wide range of chemical and industrial applications. So that's it for the video. Um, I hope you like the video. Um, if you did like the video, surely consider liking the video, and please leave a comment on what could I make some improvements on. Uh, Thank you.